In Chapter 4, we performed two tests. Our first test was between two different types of warranties, and our second test was between having the 5-year full warranty and no warranty. In our first test, we failed to reject the null hypothesis. This doesn't mean that the null hypothesis is true, just that any differences between the distributions of the two populations weren't detectable in our samples, at least to a degree that we could feel confident about. We might be worried that there is a difference, and our test just couldn't detect it. When our test fails to reject the null hypothesis, but the sample distributions are actually different, we call this a type 2 error, or a false negative. To visualize this, let's pretend our samples are different, and insert an imagined distribution for our second sample. In this visualization, any sample means drawn from the area highlighted in blue would show up in our test as a type 2 error. We call the area beta. The probability of correctly rejecting the null hypothesis when the alternative hypothesis is true is 1 minus beta. The size of beta depends on the difference between our means, the spread of our distributions, and where we set our alpha. We talked earlier about how our test might need to be more sensitive. By increasing our sample sizes, we decrease the spread of our distributions, which shrinks the beta value. Later in this chapter, we'll apply a power analysis method to estimate a better sample size for our test based on the beta value we desire. In our second test, where we compared a warranty to no warranty, we rejected the null hypothesis. In this scenario, there is a chance of a different type of error occurring, which we call the type 1 error, or a false positive. A type 1 error occurs when we incorrectly reject a true null hypothesis. The odds of a type 1 error occurring are completely dependent on our alpha. The smaller our alpha, the less chance there is of a type 1 error occurring, though this does increase the odds of a type 2 error occurring.